Welcome everybody to the next episode of Scientast the Scientast. Today we're going to be learning about the science of mocktails.
Hi, I'm Bill Lincoln, and I'm here to put some science in your drink.
Here, do you need a drink?
Yeah, I need a drink here.
So Philip, how'd you get into mocktails?
Well, you know, as a little kid, I feel like everyone has that experience of mixing orange juice and milk and finding out that it's not quite the combination that you thought it would be. So you start with your Shirley Temples, your Roy Rogers, your real simple drinks, and eventually, you know, you want to get a little more creative and do something a little bit more. And then it's one thing after another, and before it, you have all kinds of crazy stuff that you're using to make your drinks.
All you need is this.
So the element in tonic water that gives it its unique taste is quinine. It's a natural forming alkaloid in the bark of the citronella plant. And an interesting fact is it glows under UV light because quinine has a double bond, and double bond fluoresce in ultraviolet light. So if you're over your highlighter party, you can spice it up. The biggest problem you're going to encounter when you're making mocktails is that, surprise, surprise, you don't have alcohol. And that's important when it comes to extracting flavor because water is a very polar molecule, whereas alcohol is more non-polar. So they extract different things. Vanilla by itself is only partially soluble in water, so all vanilla is packaged with a little bit of alcohol in order to keep it soluble. So we found out that certain flavor compounds can be isolated, such as ethyl vanillin.
Hey, wait, I gotta stop you right there. It's called ethyl vanillin?
Yes, ethyl vanillin. This has ethyl vanillin, which is ethyl vanillin packaged with a little bit of alcohol in order to keep it soluble. This works really well for cold dishes, but if you're gonna do something hot, all the other little stuff boils off and you don't even notice the difference between this and this. The natural compounds in here, they go out of your hood, or I guess your
your baked snack.
Yeah, your baked snack. Whereas this has ethyl vanillin, which stays in your food. This is good for cold stuff. This is good for baked stuff. Now you might be wondering, what is non-alcoholic beer? Because beer usually has alcohol. Well, let me tell you, it is actually beer that they remove the alcohol from. Much in the same way that decaffeinated coffee is coffee which has the caffeine extracted. In the case of dealcoholized beer, it is usually done through either a vacuum evaporation, basically a distillation process, or through a reverse osmosis process.
Let's talk a little bit more about vacuum evaporation, maybe something you've never heard of. What most people don't know is that boiling can happen with temperature or pressure changes. So that's how vacuum evaporation works, is because you're changing the pressure and it's pulling off these things, it's evaporating it.
Perfect use of the ideal gas law.
We're nerds, let's drink. Thank you for joining us on this episode of Scientast the Scientast. We hope that you learned something about science and something about some yummy drinks.
Cheers.
Lemon,
Lemon. What do they say? Watermelon.
Lovely Lily. Okay.